just sit somewhere else. Are you going to leave it open or closed? What are you doing? Half. Fine. Okay. That's fine. Leave it. I have my coffee, so I'm good. Okay. So we'll continue with the next lesson. So I think I said later today in the tutorial class in CAV. That's at 1 o'clock, is it?
Yeah.
Or 2? 1 o'clock.
I think
It's kind of going to be like a tutorial. My plan is to do the practical problem worksheet in this class in CAB, okay? So we'll continue with the lessons in this one, and we'll have a look at the next lesson, which is exponential equations,
Are
yeah?
you going to do all the worksheet of the practice
I'm
problem?
going to try to. I'm going to try and do all the questions. Now, I don't know if I'll get through all of them, but I'll definitely do the key difficult ones, okay? So we'll try and get through all of the questions later today. Okay, so let me just grab up some examples. So what we're looking at is equations here with the powers. Let's see, maths for science. No, actually, sorry, that's wrong. What we're looking at is, I think, logs next. Is it logs next? Yeah, rules of logs. That's what we're doing next. So again, just like last time, it's not too difficult, and in fact, maybe you know some of these rules already. Let's have a look. There you go. Logs. So firstly, we need to start off with the definition of logs. So usually we write it like this: log base b and argument x, and this is called the base. So I'll explain it with an example. I find that's the best way to explain it. Like, for example, if I have log base 10 100. The way you think about this is you ask yourself, 10 to what power will make 100? So what's the answer here? 2. So the answer for this is 2. Likewise, let's say 2 8. So here, 2 to what power makes 8? 3. And this is the basic idea of logs. So if you can just write this down as a starting point.
What use is it in the assessment?
In what assessment?
Not the assessment, smart. You know the thing you're going to give us on the Excel? What's it called?
The coursework.
Yeah.
This is going, well, it's not really this lesson, but more the next lesson with logs. This is just giving us practice. But I think I was saying this to a couple of people already. These logs, they're useful for finding powers. I was saying that to somebody. Yeah, was I saying that? Yeah. Anyways, we'll just look at the basic rules. Okay. Have we got this? So just like with powers, we have rules for logs. And we'll go through the rules now. Can I scroll down? Yes? Yes? Okay. So let's have a look at the first rule of logs. Oh, well, just before going on, actually, I should point out some important things about logs. For example, like, say, log base 2 power minus 8. This is undefined, okay? We can't take a log of a negative number. And the reason for that is because we cannot think of a power that will make 2 become minus 8. We can't. It doesn't matter if the power is positive or negative. If we start with positive 2, we can't make this a negative. Because remember, all we're doing when we have a power is we're just multiplying by 2. So if they're all positive to begin with, then how can I make a negative? I can't. Okay? So we cannot take logs of negative numbers. We can just take logs of positive numbers. What about actually... No, I'll get to it later, the zero case. Alright, so the first rule, log base b of x times y. So, does anybody know what this is equal to? Log x b plus log y. So this is the first rule of logs. Yeah.
If we had a negative number in the exam or in the homework, what do we say?
Now, sometimes we do get negative numbers, but often there's a way to fix it. And later we will do, actually maybe even later today, or maybe in a different lesson, I'll look at what to do when it's negative. But usually we can remove the negative. But we won't worry about that just yet. Okay, did you write this down? Yeah? So again, just like last time, I'd like to do the proofs of these as well. You don't need the proofs for the exam of these, but it's good to see the proofs where they come from. So the way we prove this is we start off by saying let x equal bn and y equal b power m. And you can always do this. Like for example, you know, if the x was 4 and the y was 8 and the b was 2, then 4 would be 2 squared and 8 would be 2 cubed. Yeah, 2 power 3. So we say let x equal b to a power and let y equal b to a power. So that means log b xy, that will equal log b bn bm, because that's xy. But using our first rule of logs, this is log b and the power here, n plus m. So now, remember what log is. B to what power makes b power n plus m? No? N plus m. So what power do you put on b to make this? Well, obviously it's this power. So n plus m. Now, if you look at this, you realize you can rewrite the n as log bx, because if I said b to what power makes x, if you look here, b to what power makes x? It's n. And likewise, if I write log by, look in here, b to what power makes y? Well, b to the power of m makes y, so this is m and this is n. And you realize we're at the end of the proof now, because we've shown that log xy can be rewritten as log x plus log y. So this is the end of the proof. I would like you to write this down. You don't need it for the exam, but it's very good algebra practice to at least see these. Okay, did you get this? Well, I won't scroll down, I'll just write the next rule here. Log bx over y. You could probably guess what it is if you didn't even know it. It's minus, isn't it? Log x minus log y. So this is rule number 2. Rule 1, rule 2. Okay, continue. So I'll prove the second rule, and the proof is so similar to the first proof. All I'll do is I'll use green to show you the difference. So let's look at the first proof again. Instead of log x multiply y, what would it be? It'll be divide. So I'll just write a divide here. Instead of bn multiply bm, it's bn divide bm. So instead of plus here, it's minus. So instead of plus here, it's minus, and instead of plus here, it's minus. So the proof is so similar to the first one. So similar to the first one. So you don't even have to write it down. So you can even just say it's, you know, Where's my pen gone? C proof 1. Okay. Can I scroll down? Okay, so rule 3. So for this one, we can say log b x power n. Does anybody know this rule? It's n log x. Yeah. Yeah. Okay. Again, we'll do the proof for this one. And in fact, the proof for this one, you can use the first rule. Because what you can say is log b x n, that's equal to log b x x x x dot dot dot. How many x's will I have? N x's. So using the first rule, we know we can write this as log bx plus log bx and so on, etc. And there's n of them, so we've seen this trick before. It's just going to be n log bx. And now again, that's the end of this proof. Rule 4 then. Log x y, that's equal to 1 over log, does anyone know this one? Yx. So you can swap the base and the argument, but the price you pay for making the swap is that it gets flipped upside down. So if you were to swap the x with the y, like here, the price is it gets flipped upside down. Okay?
Well, why did we strip in the first place?
Well, for problems you'll see later, maybe the thing we want is in the base. So we want to get it out from the base. So we might swap it like this. Okay, so again, I've done 3 proofs for you. So just as a little bit of practice, I'd like you to see if you can try and prove this result for yourself. So you've seen 3 proofs already, and you've kind of seen the technique. Huh? 3 proofs. Because this is rule 4. You are going to make the 4th proof. So just try for a minute or two, see if you can try to prove this result, okay? Can I scroll down a bit? Yeah. Just spend 2 or 3 minutes, just see if you can try and prove this result. Okay. What do we think is a good starting point here? No? Well, I think as a starting point you can do the same trick I did before. You can say, let x equal b to some power, and let y equal b to some power. And in fact, the b is not important at all. So, in other words, you write x and y as powers. So, for example, again, if x, let's say, was 2, and let's say y is 8, then you could say x equals 2 power 1, and y equals 2 power 3. So, we just imagine that we can write them as powers. So, let's start the proof. Oh, sorry. X equals bn and y equals bn. So we let this, assume this. Okay. So log xy, that's equal to log bn bm. Now, I think some people will know what this is. If you just think really carefully, you can tell me what this equals. M over n. Because remember what this stands for. You're saying Bn to what power equals Bm. So what power do I put here to make this true? I could put m over n, because then these will cancel and I'll have my m that I want. So this here is m over n. What I can do now is change this into 1 over n over m. That's the same thing. And using my trick from this step, but backwards, I can change n over m into log bm bn, because this is the same as n over m. It's the same idea as here. But what's bm? What's bm? Y. And what's bn? X. So this is the end of the proof for rule 4 then. So if you got that, great. If not, don't worry. I just wanted you to practice. If you didn't get it, if you can write this down now, please. Did anybody get it? I didn't expect. I just hoped. I didn't expect anybody to get it. Just hoped somebody might. Okay. Can I scroll down? Yeah. So there's only 2 more rules to do, and the last rule is easy because it's like last time where it's just to do with ones and zeros. So rule 5 is similar to rule 4, and in rule 5 it's when you want to change it to any base. So for example, you start with base B, but you don't want base B, maybe you want another base like base C or A or whatever. So when you change the base, let's say we change the base from B to C, the price you pay for making that change is you must divide now by log base C of the old base. So if you want to change from a base B to a base C, then the price that's paid for doing that is you have to divide by this. So again, we'll prove this. If you can just write this rule down. Okay. You have this? Yeah? Okay. So we'll start the proof again. We have log base bx. So what do we think might be a starting point this time, now that you've seen a few proofs? We usually start off by letting Yeah, so we can say let x equals something, and what do we think? Yeah, you see, you kind of have a choice here. You could say let x equals b to some power, but also we have this c here as well. Yeah, so maybe we could say something like let x equal c or b. Let's see what happens if we try it with b, and if it doesn't work, we can just change to c. So you don't have to write it down just yet, because we need to see which one will work. We'll say let x equal b power n, and then let c equal, what do you think? Again, b power m, something like this. So let's see what we can do with this if we were to make this substitution. So this will be log b, and up the top here, this would be bn. So it's n then. So that doesn't seem too helpful, does it? I mean, what do we continue with next? So why don't we try it the other way? Why don't we try, instead of b, we could go with c. So let x equals cn, and then let b equals cm then. Right, so what would this be? This would be log cm, and then up here, cn. Okay, so this looks a little bit better than last time. What will this equal? N over m, like this. Yeah? And you realize, oh, actually, we're nearly finished, because if you look at this, what can we say the n is as a log? It's log cx, because if you think about it, c to what power makes x? C power n makes x, so this is the same as n. And then at the bottom, what could that be? Log c b, because c to what power makes b? C power of m makes b. So then we've finished the proof already. So you can see that the trick to proving these is making a good choice at the start for a substitution. And then once you make the right choice, the proof is not too bad. So if you can write this one down, please, and then there's just one left. Am I just missing Adnan, is this? Yeah? Okay. Okay, do we have this one? Yep. So, let's have a look at the last one, which is rule 6, which is more just some definitions. Log base b of 1. So, b to what power makes 1? Yeah, what is it? 0. So this is equal to 0. Some other basic definitions. Log b to what power makes b? 1 then. Also, log b of a negative is undefined, yes. Well, not that it's undefined, it's not a real number, so it's not a real number. Which is a little bit different to undefined. And then lastly, log b 0. So b to what power makes 0? B to what power makes 0? Yeah. So let's say 2. 2 to what power makes 0? No, because 2 power 0 makes 1. Yeah, there's no number. In fact, it's not defined, or really it's kind of like minus infinity, I think, but we'll just say NA. I'm not 100% sure if it's plus minus infinity. Well, minus infinity. I think it's minus infinity. Yeah. It does. Now usually we only use B as positive numbers. And not only positives, but usually bigger than 1. 0 to infinity is what we usually use for B. Oh, for this one here? think so. Like if I had log 0.50, it's still the same problem. I can't think of a number that will make this become 0. Yeah. Plus infinity, yeah.
Is there a calculator trick over here? You want like just anything with the calculator?
You can change the base in the calculator. Yeah. Now, just before I do some examples, talk a little bit about the minus problem here. Sometimes you get minus in the exam, but it's actually not really a minus. You can actually fix it pretty easily. I'll give you a very basic example.
Isn't to the power of minus 1?
For minus,
It's like log of minus 8 to the base b is 8 to the power of. Isn't it something to the power of minus 1 or something?
don't know what you're asking me. Yeah, I'm going to continue. Log, let's say you had a problem like this. Log base, it doesn't matter, I'll just say b, of minus 2 plus log base, let's say, minus 4. Now you might think, oh, this is a problem because I don't know each of these. But it's not really a problem because you can use the first rule of logs to simplify. The first rule says that you multiply. So minus 2 multiply minus 4 is positive 8. So this is okay. This is not okay and this is not okay, but when you put them together, it is okay. It's a bit like with the square root. This is a problem, yes? But if I had something like this, so this is no good. If I had square root minus 1 multiplied by minus 2, is this a problem? No, because this can be made to be positive. So often in the exam, when a minus appears, it's only temporary. There should be some way to get rid of it, like in my example.
This is the only way to get rid of it?
This is the only way for the exam. Yeah. Right, can I scroll down? Do you have this rule 6? Yeah. Right, so let's have a look at some examples now. So let's take something, I'll give you some to try. Let's put in some numbers. Don't use the calculator. Log 2, 512, log 5, 25. Actually, that's an easier one. You should do that one first. Log 5, 25. Log 2, 512. Oh, and I don't know. Log 2. $2,048. Okay. Okay, so what's the first one? 2, because 5 to the power of 2 makes 25. The next one, let me think, 2, 4, 8, 16, 32, 64, 128, 256, 512. That's a 9. And is this 11? You can check on your calculator. Does 2 power 11 make 2048? Is it? Yeah. Is it 12? It is 11? Okay. Wait, it can't be both. It is 11?
Yeah.
Okay, fine. Okay, so that's our first example, just to get started. Let's look at something a little bit trickier. Can I scroll down a bit? Yep. So, here's a couple I want to simplify. I want to simplify 1 over log 2x. I want to simplify log x1. And I want to simplify log x 35 plus log x 5. So, for the first one, what rule can I use if I want to simplify it a little bit? Yeah, the one that lets me swap. So, I can swap this back to log x2. Okay, this one's pretty good. In fact, I know the answer. X to what power makes 1? So this is a 0. And what rule can I use to simplify this? The first rule, which will be log 35 times 5, which is 175? No, that's not right. 175, isn't it? Yeah. Log x 175. And this is using rule 1, this one is using rule 6, and this one is using rule 4, wasn't it? Yeah.
Yeah.
Okay. Right, let's look at ones a little bit more difficult now. If you can write these down. Can I scroll down? Yep. So I'll give you some more to try, but this time they're a little bit longer. Just try this one first. 3 log 2 4 plus 9 log 8 2 minus 2 log 2 8. And what you need to do is you need to simplify this first. So for example, what's the first problem here? Well, the first problem I can see straight away is that this is base 2, this is base 2, but this one's base 8. And as a little trick, these are much easier if they're all the same base. So the first thing you should try to do is to change this base to a 2. Yeah, so you could actually do the swap, and this will be log 2 8. Okay. So try this for a minute, see if you can simplify it, then I'll do it. Oh, and just before you actually do it, just to say, can you look up for just one moment? If I have this, okay, this is not bxy. You can only use the rule when it's 1 and 1, yeah. Yeah, you can't just put them together. It has to be 1 log and 1 log to put them together. Okay, now try this.
You mean 1 or any number?
Or the same number, at least, yeah. Okay, let's have a look at this one. So what I would like to do is I would like to practice my rules by putting this all together into one. So the first thing I'll do is I'll do a swap here and change this into 9 over log 2 8 minus 2 log 2 8. So if I wanted to put the first one with the last one, I can't because I have a 2 here and a 3 here. So if I wanted to put them together, I need to make it the same. What I could do is bring the 3 back up as a power. This is like rule 3. So this could be log 2 4 cubed, which whatever it is, minus log 2 8 squared, plus, now I know you can calculate these, but I'm just trying to practice the rules, What's log 2/8? 3 here, yeah. Now, if I wanted to put these together, what rule is that? The second rule. So this is log 2, and on the top is 4 cubed, and on the bottom is 8 squared. And this here is 3. Okay, so on the top, what is 4 cubed? That's 64. Oh, and the bottom is 64 as well, isn't it? So this is just log 2, 1. And what is log 2, 1? Yeah. So the answer is 3. Now this isn't the only way to do it. In fact, if you wanted to, you could have just calculated this here. This would have been 2 by 3, 6. And then this is a 6 as well, and they would have cancelled here. But I just did this to practice the rules more, okay? So if you can write this one down, please. Yeah, but this is no good for the exam. Yeah, but you can check, and it should say 3. Yeah. Okay, did you write this one down?
Why do you put 9 over log 8 in base 2 instead of log 1?
Which one here?
Yeah.
But I swapped the 2 and the 8.
No. Why was it 9 1?
Oh, because it's 9 times this, and this is the thing that gets flipped. The 9 is away from that. Okay. Did you write this down? Yeah. Can I scroll down? Yeah. Okay, so last time we were looking at this very important power. For example, e power 2, that's 2.71828 power 2. And we would like to work backwards. So for, can somebody actually tell me what this is? What was it? 4 point something was it? No, I don't remember. What was it? What was it? 7.389. Was it? So you could go backwards, of course. You could say log base e 7.389. So this is asking e to what power makes 7.389, and we know the answer. What is it? 2. Yeah, because from the previous. E to the power of 2 makes 7.389. Yeah. And in fact, again, because this is so important, it has a built-in function on the calculator called natural log. On the calculator, you see this button called ln. This ln button is exactly the same as log base e. So if you type in ln 7.389, that's the same as log base e 7.389, and you should get roughly 2 on the calculator. 1.99.
Yeah, which part?
No, it's up the top right there. Roughly 2.
E to the power of 2, right?
Yeah.
So if you put 2 on the other side and get log of e.
Alright. Oh yeah.
And then try to log of the thing. Could you solve it that way?
Huh? Here.
Yeah. We did 2 log e and then 2 log.
Yeah, but you don't. If you didn't know that, you would have no way of knowing that this is e squared. So. Okay. Hey. So, natural log is a very important log. Its base is always e. I'll say this, and some of you will still screw this up in the exam, so I'll say it more than once. On your calculator, you will see this button, ln, and you will see this button, log. These are not the same. This is log base e. This is log base 10. why will you make this mistake? Because often in the exam, they don't write ln. I mean, sometimes they do, but sometimes they write log, base e, or sometimes they just write log. If there is no base, you assume the base is e in maths. And you can only do this in maths, not in other subjects that use log. So in maths class, if the base is not present, if they just write log, you can assume it's base e. So what will happen in the exam is you'll get a question like log 5, and students say, oh, log 5, okay, so I'll hit this button, and then they'll get the wrong answer, because really, it's still this. So these are not the same. As a good rule, for us, we hardly ever use this. I mean, 99% of the time it's going to be this, and maybe 1% of the time it will actually be base 10. But in maths class, base E is the usual base. I think in chemistry maybe you might use base 10, maybe. This is with pH levels, yeah. But for maths class, not the normal. It's normally base E. Okay. So again, chances are, if you're pressing log on your calculator in the maths exam, you should always be pressing ln. Think very carefully if you press log, ask yourself, is this the right one? Am I really using base 10 for this question? Okay. So now we'll have a look at the graph for log x. Can I scroll down? Yeah? Yes. I can tell the time, so your contribution is not welcomed or useful, thank you. Y equals a log, well, let's just do log x first by itself. Y equals log x. This is x, and this is y. So, what's log 1? It's 0. And what is log of, let's say, e? So what is log of e? What is log e? 1. So here, e will be 1. And you can check this on your calculator. If you have log of a number between 0 and 1, it'll be negative. So for example, log 0.5 is minus whatever. Now this confuses people. Just remember earlier I said we cannot do log of a negative. Right? I said that. But I didn't say the answer couldn't be negative. Yeah. So the answer could be positive, 0 or negative. It's just that we can't put a negative in. That's all I meant earlier. So this is the graph of log x. And this graph grows slowly. So it's not like the exponential. It's actually the opposite. It grows rather slowly. In fact, it looks quite flat, but it's still actually growing. Okay? So if we can draw this, and then we'll look at some other possibilities. Oh yeah, and actually, what about over on this side? What happens here, do you think? Well, on this side there's no graph. Why not? Yeah, I remember we cannot use negative x in the log. So there's actually no graph here on the left. And as you move towards 0, this shoots down to infinity, minus infinity. So, can I scroll down? We have less to look at here. Last time we looked at y equals a bx, and here we have y equals a log x. Why do I not need to consider the b here? Why do I not need the b here? Remember that? It can't be negative, so there's no point in looking at the positive or the negative possibility here. It can't be negative. So it's only the a that can be positive or negative. The b can't be negative because we need to keep it positive. I mean, you could put the b in to be positive or negative, but it doesn't have a big deal. let's just quickly do these. A is positive, B is positive, A is negative, B is positive, A is negative, oh that's the same one, sorry. A is positive, B is negative, and lastly A is negative and B is negative. Okay, so the first one, A is positive, B is positive, goes like this. Next one, A is positive, B is negative. It flips, very good, it flips it around to the other side, so it goes like this.
Reflection on the wall.
Yeah, A is negative and B is positive, so it's like this. And lastly, A is negative and B is negative. I have to use all my imagination power here. Flip and flip.
Reflection on won't it be a reflection on why it is there?
This is it. I think. Anyways, it's no. It's not. Well, for the exam, they only ever ask you for the exam to draw these two, anyways. No, sorry, my mistake. They only. Yeah. They only ever ask you to draw these two for the exam. So for the exam, you just need to worry about those two, anyways. Okay, the homework, ABC for the homework, yeah? Hang on, one at a time. You first then.
Is it B or X? Y is equal to A.
Oh yeah, sorry. So what I did go for the A log BX, but my point was for the exam, they don't usually put the B in here. They just keep it as a positive. It's only the first two we really care about for the exam. The A positive is on the top and negative is flipped down to the bottom. That's all. Yep. Yeah. I really misspoke. I should say the BX is always positive. So if the B is negative, then we're forced to make the X negative. So the effect is to flip the graph over. Yeah. So I should have really said the BX is always positive. Okay, we're finished there.
So this is for both equations, right? Y equals AE BX and Y equals...
No, sorry, I was just comparing this with yesterday. It's for this one.
Log A...
Log A log BX.
Okay.
Okay, closing this.